Hello grade 12s, welcome to my channel, and let us have a look at this question. It was shared to me by one of my students, and hopefully it can help you as well to practice. So we are going to apply our three-step approach in doing this. So we've got this question here. We need to prove the identity. And obviously from inspection, we're going to see that we've got cos 2 theta, and this is far more complicated than just cos 2 theta. So it wouldn't make sense to choose the left-hand side, but we better choose the right-hand side. The right-hand side is this ratio, 1 minus tan squared theta over square root 1 plus 2 tan squared theta plus 10 to the exponent 4 theta. Now remember guys, these kinds of questions, they need a strategy. Now something like the three-step approach is the best way, because you would wander off into the sunset here and come back empty-handed, okay? So let's see. Do you immediately change the tens? The answer is perhaps, but you see this expression is already complicated. So we see that this is a difference of two squares. We can actually factorize that thing, okay? That's just what we can see. Because we don't have any like terms, there's no brackets, we can't handle this. But if we look at the denominator, we've got the square root sign. Now square root sign speaks to something like exponents and stuff. Now the reverse approach to this, or the reverse operation, is to try and remove the square root. Now how do we do that? Of course we can't just square here, we don't have any equation. So this means we need to simplify. Now if you look at this guys, just take a look. What do we see? This is a trinomial. And it's a trinomial such that the highest power is the exponent 4. And the second is the exponent 2. And what do we see here? These are somewhat related. So this means we can actually factorize that expression under the square root sign. Now that's the approach. Can you see? We saw that BODMAS, not so much, but we're trying to get back to it. But this is a trinomial, and that's a difference of two squares. But remember, that is squared, and we want to get to cos 2 theta, so we can leave that for now, so that we don't complicate ourselves, or our lives at least. Okay, so we have 1 minus, I don't know why I don't write so well. Okay, that's the story. So this is the square root of. Now for us to factorize this thing, we know that this is the highest exponent. So this should be 10 to the exponent 2 of theta. And this will still be 10 squared theta. Now to get it to there, this should be plus 1 plus 1. Really the order doesn't matter here. And we can see that 10 squared theta times 10 squared theta gives us 10 to the exponent 4 theta. And 10 theta times 1, 10 theta times 1, those added, they give us 2 10 squared theta. 1 times 1 gives us 1. So these are some of the tricks. And can you see guys, this bracket is exactly the same as the next bracket. So this already tells us that we are winning. So we have 1 minus 10 squared theta divided by the square root. Now here we can write 10 squared theta plus 1 all squared, because that bracket is repeated. And guess what? The magic happens now. That takes out the square root. We are finally off the hook for now. So we've got 1 minus 10 squared theta divided by 10 squared theta plus 1. Now here, even if we try to factorize by taking out the highest common factor, which is a negative, this becomes 10 squared theta minus 1. So these ones are never going to look alike. That's a difference of 2 squares, but we don't need to factorize because we cannot factorize that denominator. So now this goes back to saying identities. What do we know about identities? 10 can be expressed as sine. But now we're going to split these terms. We're going to have 1 minus 10 squared theta is nothing but sine squared theta over cos squared theta. Then we say divide by 10 is nothing but sine squared theta over cos squared theta. That's the denominator there, plus 1. Okay, so we are winning. So on the left hand side, we look for the common denominator, which is cos squared theta. And what do we do here? This is over 1. So cos squared theta divided by 1 is cos squared theta. Cos squared theta times the numerator is just cos squared theta. Then we say cos squared theta divided by cos squared theta is 1. 1 times the numerator, we remain with sine squared theta. Okay, so this is divided by, we want to get to this one. Again, this is as good as over 1. Cos squared theta is our common denominator. Now cos squared theta divided by cos squared theta, that's 1. 1 times the numerator is sine squared theta plus cos squared theta divided by 1, that's cos squared theta, times 1, it's cos squared theta. Alright, so let's get to the business, nice and easy. What do we see there, guys? This is an identity, right? Yes, it's an identity. So at this point, we can just shrink it because this is the cosine double angle identity expanded. So this is the same as cos 2 theta divided by, we remain with cos squared theta. At this point here, just want to simplify. Again, we see another identity. This is the square identity. So this is as good as 1 divided by cos squared theta. Now cos 2 theta over cos squared theta, we then flip this one, it becomes cos squared theta over 1. And the final magic takes place. This is nothing but cos 2 theta. And this is equal to the left hand side. The identity has been proven. Okay, as you can see, guys, this is a little bit intensive. It takes a bit of, comfortability handling these kinds of questions. But at the same time, when the strategy of the 3-step approach is applied, and as you can see, I didn't even need to write it out. If you have understood it and you can use it well, you get your marks with no pain whatsoever. So I hope you guys are good. Anyway, let's see, how many marks would you score here? Whenever we factorize, we get a mark. Remember, if we use the 3-step approach, we get marks in the simplification itself, not a big deal. And of course, we get a mark for this and that because we are using identities. That is 3 marks. And when we shrink this into that, that's a mark. When we shrink that into that, that's a mark. Using identities. Remember, fractions, it's not a big deal. It's BODMAS, nothing else. So how many marks? 1, 2, 3, 4, 5. Okay. Great. So essentially, guys, yeah, man, I don't know where's this other mark. So maybe 5 marks because this was the answer anyway. So for me, this is essentially 5 marks. Alright guys, so I hope you enjoyed that video and give it a thumbs up and keep practicing as many questions of this nature as you can so that you can get comfortable and go and score those marks in your next exam. Otherwise, I'll see you again next time. Goodbye.